Future technologies and processes. So when we're considering future technologies and processes, we need to think of why we are using our science to develop new things. And we really need to meet the needs of society. So let's dig into what those needs might be. And here's a very short list. You might think of others. So we might need faster and more efficient transport, greater use of low carbon energy. So that's all linked in with the climate change, more food resources with better nutrition so that we can feed a growing world, more efficient and sustainable food production, same idea, reducing pollution, that's all about sustainability, so we have a planet to live on in years to come, and energy efficient housing, that brings in quite a few of those ideas. So can scientific developments really meet our needs? Well, there are three ideas we're going to meet here: technology, biotechnology, and advanced biotechnology. And we've got definitions of these. Technology is the application of any scientific knowledge for practical purposes. Now, if it's biotechnology, we are now applying our scientific knowledge of living organisms to do work for us, to make a product. And if it's advanced biotechnology, not only are we using living organisms, but we are using our understanding of genetic technology to apply that to living organisms to make them solve problems for us or make products. So in amongst all of this, we're making new materials and using new processes to meet our needs. In amongst all of this, we need to remember to act in a way that is humane, justified, ethical, and sustainable when we are developing new products and new processes. So to be humane is to do something which acts in a kind or sympathetic way to other peoples or animals or plants and try to do as little harm as possible. Justified means that what we are doing has a real and legitimate reason for doing it. We need to be ethical, where we think about the rights and wrongs of doing something. Just because we can do something, does that mean that we should do something? So we need to consider well-being benefits, individuals' rights, individuals' choice, respect privacy. That's particularly important in the field of genetics, thinking about the privacy of genetic information for generations to come, as well as fairness. Is it equitable across different countries and different people in the world? And the last one is sustainable. So we need to make sure that the process or the product meets the needs of society today, but also into the future without damaging the environment or making it impossible for future generations to live. Now, we have been playing around with biotechnology for a long time. So here are some examples of fermentation by microbes. So lots of different fermented foods, making bread, making beer, using bacteria and yeast to do these various fermentations. So this is not necessarily a new thing that science has been used to make new products and processes. We have been doing biotechnology without genetics for a long time, so selective breeding to have domesticated cattle that are high milk yielding, for example, or changing what wild wheat looks like so that we can harvest really sophisticated, high yielding bread wheat, which all grows at the same time, at the same height, so we can use our machinery to collect it. But we have moved into the world of genetic technology, and there's a whole load of examples here where we can genetically modify organisms to make things for us. Now, we can look at developing materials as well. We have had ancient materials that we have put to use for thousands of years. So we've got a little graph here: Stone Age, Bronze Age, Iron Age, and we have also been able to create modern materials. So plastics and polymers are good examples. But also we are able to make new materials now, applying our understanding of chemistry and physics to nanotechnology. That's technology on a very small scale. And I've got two examples here: nanotechnology being used in textiles and nanotechnology in food industry. There are many other examples of nanotechnology being used, but this is, you're looking at technology at the atomic or subatomic level to actually do advanced things that meet our needs. And we also can think about both nano and other technologies in the world of computer processing. And we've got some key components here of AI, which is artificial intelligence. And that does not mean robots that look like people. It means all sorts of different things that we can use this high-speed computer processing power and our understanding of how that interfaces with humanity to have artificial intelligence to do jobs, processes for us much faster, more efficiently to meet the needs of society today.